Hello, and welcome to Empowered Learning. This is the fourth example on graphing rational functions. The function that we have now is h of x is equal to 2x squared minus 3x minus 9. All of that divided by x squared minus 2x minus 3. So for this one, just like how we've done in the other examples, we want to look at our rational function factored out as much as possible before we begin. So here, we're going to factor out the denominator first. And so we see here that if we factor this out, we should have x and x. And since this is minus minus, one of these should be plus and the other should be minus. And then here we know that the factors of 3 is just 3 and 1. So 3, which is the bigger one, needs to be by the negative, and 1, which is the smaller, needs to be by the addition sign. Okay, so same thing for the numerator. We'll go ahead and factor this out, and we know that we have minus minus, so 1 has to be a plus, 1 has to be a minus, and since our first term is 2x squared, then this would have to be 2x, and this would have to be x. And so then from there, the factors of 9, the ones that we'll probably use here is just 3 and 3. So we'll put 3 here, put 3 there, and we multiply this out. We have 2x minus 3x, which is a negative 6x. So we'll try to get that drawn correctly here. And then when we multiply the inner, we see that we have plus 3x. Try that again. Plus 3x, and of course that gives us a net result of negative 3x, which is exactly what we need here. So we know that we have this factored out correctly. Alright, so now that we have that factored out correctly here, the next thing that we're worried about is, do we have any holes? And we see we have common factor in the numerator and denominator of x minus 3. So here we will reduce those to 1, and what we're left with is 2x plus 3 divided by x plus 1, and that reduces to 1. But where we have a hole at x equals 3, and that is the location as far as x value for where it is. Since we have a hole, we're going to plug in 3 into our reduced form of our function to figure out where the actual point location is by finding the y value. So if we come here, we have h of 3, and this is in reduced form. This will be 2 times 3 2 times 3 plus 3, all that divided by 3 plus 1. So that ends up giving us just 9 over 4, or 2.5 if you want to think about it in terms of decimals. Alright, so we know that from this, that this function has a hole located at the point 3, 9/4, which is like 3, 2.5, as far as the x and y coordinates respectively. So now that we know we have a hole here, we're going to be looking at this form of the rational function for all the other questions that we need to ask about it, or trying to figure out the other properties about it. So we know we need to find out where our x-intercepts are, y-intercepts, as well as whether we have any vertical asymptotes, and do we have a horizontal or oblique asymptote. And of course, We want to find out if the function crosses the horizontal or oblique asymptote or not, as well as the behavior around the vertical asymptotes. So for the x-intercept, we know that it's going to be the zeros of the numerator. So if we take 2x plus 3 and set it equal to 0, if we subtract 3 from both sides and then divide by 2, we'll see that we get x is equal to -3/2. So that means that our x-intercept will be at the point -3/2, comma 0. Or put another way, -1.50. For our y-intercept, we just plug in 0 for h. And in doing that, we get 2 times 0 plus 3. All that divided by 0 plus 1, which ends up just being 3 here, because all that goes to 0. You know, all this is just 1, so 0 plus 3 is 3, and all that over 1, 3 over 1 is just 3. So y-intercept is at the point 0, 3. For our vertical asymptotes, we see that we only have one factor in the denominator, so thus our vertical asymptote must be at x equals -1, since -1 is the number that makes the denominator 0. Now looking at to see whether we have a horizontal or oblique asymptote, again we see that the degree of the numerator, which is 1 here, is the same as the degree of the denominator, which is 1. So in this case, we will be dividing leading coefficients. The leading coefficient of the numerator is 2. The leading coefficient of the denominator is 1. So therefore, we have y equals 2 as our horizontal asymptote. So here we definitely know we have a horizontal asymptote, and it is at y equals 2. So we'll do some separation there. Now, we've covered everything except for the last two things. And those last two things is, will this particular function cross the horizontal asymptote at any time, as well as what is the behavior of the vertical asymptotes, or vertical asymptote in this case, for the function. So we're going to be looking at 2x plus 3 divided by x plus 1, the reduced form of a rational function from here on out. We're going to use that to be able to figure out those last two questions. So first thing is we want to know, does our particular function cross the horizontal asymptote of y equals 2? So to do that, we just set this equal to one another and see what we get. So here we have 2x plus 3 divided by x plus 1, all that equals 2. And so from there, if we go ahead and solve this, we can put this over 1 and cross multiply again. Then we have 2x plus 3 equals 2 times x plus 1. And so from there, we have 2x plus 3, and we'll distribute the 2 there, so that'll be 2x plus 2. And of course, by subtracting both sides by 2x, we see that the x's virtually go away, and now we have x is equal to 2, which implies no solution. And thus, we know that the function h of x does not cross the horizontal asymptote at any time. So the last thing that we need to talk about is the behavior of the function around the vertical asymptote x equals -1. So here we will say near x equals 1. We have h of 1, and we'll plug that into the numerator, but not the denominator. And again, we will not plug it into the denominator because, sorry, -1. Yeah, we will not plug it into the denominator because -1 is going to make the denominator 0, and we already know that. So we have 2 that's not working, so we'll try it another way. So we have 2 times a -1 plus 3, all that divided by x plus 1. Okay? And so, of course, 2 times -1 is a -2, and a -2 plus 3 is a +1 over x plus 1. And so, of course, this looks like 1 over x. It is just horizontally shifted to the left 1 unit. So now we have everything that we need to be able to sketch a graph of this particular function. So let's go ahead and move on to the graph. All right, so we've moved on to the graph portion, and now what we're going to do is take everything that we found and put it into our graph and see what the final graph looks like. So for starters, we found out that we had a hole at the point 3, 9/4. So I'm going to come here and say do half units again. So let me go ahead and label that. 5 there and -5 there. So at the point 3, 9/4, we will come and do this. And so this is 1, 2, 3, and then 9/4 is like 2.5. So that's 1, 2.5. And so there we will have our hole. Okay. All right. In addition to that, we know that we have a x-intercept at -3/2 or -1.5. So that will be here. We know we have our y-intercept at the point 0, 3. So that's 1, 2, 3. And we know we have a vertical asymptote at x equals -1. So that would be around here. And we also have a horizontal asymptote at y equals 2. So that would be here. So now, of course, the last thing that we need to do is put in our information about the behavior around the vertical asymptote x equals -1. So if you remember, we said that our function acts a lot like the graph of 1 over x plus 1, meaning just like 1 over x just shifted over horizontally by 1 unit. So we know that over here it's going to start like this and eventually kind of swoop this way. And then on this side, this starts down like this and eventually swoops this way, knowing that we have to go through that x-intercept right there. Okay? And we also know that the function does not cross the horizontal asymptote at any time. So now we're going to go ahead and put everything together and draw our final graph here. So on the left side, we know that we're going to have to come through here, go down like that, and on this side, come and right along the horizontal asymptote. On the right side, we start up here at the top, got to go through the y-intercept, got to go through the hole, and then right along the line y equals 2. And so this is what the graph of this function looks like. So please check out the next example.